you can be anything. So once you are an agronomist, then you can learn many things, and you can also recently there was a statistics done by ICR. They found that wherever agronomists are located as a head of the institutes, they are excelling much more because they know everything from the how to manage things and how to. That is the thing. I think agronomists have an additional advantage. So you should feel proud about your own subject, and you should also excel it. And you are working for a very important person, that is a farmer, and you can make a change of farmer's life and a farming community. Small interventions also will make a lot of difference. That you should understand. Whatever you are planning, whenever you are planning something, can I make any change in the society? Can I make any change in the farming community? How my work will be useful for the farmers? That you need to question yourself. Then you can start your work in the in your not only in MSc and PhD. With this small background, I think Madam has already given my little bit brief introduction. I am very proud to say that I worked in more than 32 years in rice research. So I don't know other than rice crop. So every day in and day out, I used to see only rice crop, because my first posting itself in directorate, then it is directorate of rice research, and now it is been upgraded as Indian Institute of Rice Research. So I am working there for last 32 years. I think I am focusing more on the water management. You all know that. I think I think student has already given a very brief introduction of rice. I am not. This is what I think where I am working. I started working in All India Coordinated Rice Improvement Project. So our main activity is to coordinate the rice research. Why we should coordinate the rice research? So that you will be knowing it. Rice can be grown in many situations. So I cannot do the research by just sitting in the Hyderabad. The requirements of deep water rice, I may not be knowing requirement of upland rice. So that's why it was thought that we need to have a All India Coordinated Rice Improvement System project, so that we through our institute, we employ some of the scientists there, and they will be working on a common understanding, and they will be developing their own technologies. So later it became as the Directorate of Rice Research, where we have started working on irrigated ecology, because 2 rice institutes are there. I think for the benefit of our students, we have one more institute is National Rice Research Institute at Cuttack. So everybody was questioning why 2 institutes in India like that. So what we have done is, for DRR we made it irrigated rice ecology. For NRRI, National Rice Research Institute, which is located at Cuttack, has given rain-fed rice. And now recently, I think 2014, we have become as Indian Institute of Rice Research. This is our mandate, and we have a vision to help the farming community, rice farmers, and which are largest in the country. We have not many linkages, as Madam told. We have, I think, everywhere. I think that is, I feel very proud. Wherever I go, I will be identified as a rice scientist, and we have many centers across the country. And at a particular time, more than 1,000 scientists will be working on single crop. So that is a very big strength. I think in the world also there is no other crop having so much of network where they develop the technologies for rice research. And one more good thing is, sir, we are also taking students for last 4-5 years. I think at particular year, there are more than 100 students. They are working in the Rice Research Institute, not only biotechnology, agronomy, and other things. So we have a MOU with all Raipur Agriculture University, many universities like Angru, PJTSAU, not only nearby, but people come from now. I think ICR has a plan to have a IRI hub. So they will be taking students for BSc, MSc, and PhD. and we are also one of the partners of that IRI hub. So we are linkages with many them BHU also, US, Bangalore. So I think anybody, I think in future, if any requirement, if somebody wants specifically work on rice, and they can, I think, win-win for both of us. We also get good work, and your institute also will get good name with working with us. We are open for that, and ICR is now opening up. They are also trying to collaborate with private agencies and also even that incubators. We are also working with small companies who are incubated for them for the technologies we wanted to promote it. This is the reason why I think ECRIP system has started. There is a different diversity, and this is the only crop which come up with more water and also less water. Maize, if it is 4 or 5 days of inundation, we cannot get anything from the maize crop. So this is a crop. I think this can be grown even 1 meter depth of water. And the interesting thing is, as the water rises, this plant also rises. It is so much accustomed to the various situations, and it is really a worthy crop to work on this for enhancing this. You can also see that I think you all, I think, very near to the Kerala Kuttanadu area, where that crop is below sea level, 1 meter below sea level. Interesting thing is, people will drain out the water from the field. That is where they use lot of energy for draining out the water. And whereas in other places we need to put the water for this. That area is more than 1 to 1.5 lakh hectares. That Kuttanadu area where it is below sea level. They will make barrier and they will try to pump out the water whenever they get excess water. And also it can also grow in 3,000 meters above sea level, where we cannot walk also. That is the situation, but rice crop can sustain it and produce. So there are different challenges are there. I think land is, I think we were at 32 to 33 million hectares when we got independence, and now it has 42 million hectares. But another coming days, it will come down to again 38 million hectares. But still, we need to produce more rice. So land will be going to be very crucial. Labor, then you must have already thought of, many people must have heard about climate change and soil health. There are so many environmental concerns. Cost of cultivation, somebody already spoke about cost of cultivation. I am more focusing on the water, how best water can be saved. Water, I think why this water is very important for rice crop is, it takes lot of water, 1200 mm water to produce 1 hectare of water, 1 hectare area. So roughly it is 4,000 to 5,000 liters of water to produce 1 kg of grain. So imagine it. That's why people earlier, our elders used to say that never waste water. If you are wasting water, never waste your food, especially annam. So why they say that so much of inputs like water are being used for the production of the rice crop. So that is the reason. So we have to be very careful. This is the status of rice at present, and you may be surprised to hear that when recently, I think you must have seen in the papers and other things, exactly 30 days back or something like that. When India decided to ban the export of rice, there was a lot of hue and cry in USA, and there are a lot of stocks have been exhausted. Rice, whatever that is stored is been. So even just stopping for few days of export also will create so much of havoc across the globe. And you may be surprised to hear that actually our requirement is only 90 million tons, but we are producing around 129 or 130 million tons, and most of them we are exporting it. Some of the countries, they will not sustain if you are stop sending that, if you stop sending the rice crop. So some of the African countries, I think there is, I don't have the list, but 20 countries which solely depend upon our rice export. They cannot survive. So that's why enhancing the rice production is very much important. And not only that, we are more than 60 to 65% of people are growing rice crop. and more than 90% of people consume the rice for their livelihood. And it is another thing is 89,000 crores, 82,000 crores. 89,000 crores is foreign exchange. That it should be very. But at the same time, I want to say that we have to be very what is that careful about exporting rice, because indirectly we are also exporting the water. Suppose 1 ton of rice we are exporting, then so much of water also exporting. So now we need to think about how rice can be grown with less water. These are all other challenges, but last 10 years, rice production has been stagnated. Earlier it was 2 diseases, now it has been 15 diseases are prevalent. Earlier it is 2, 3 pests, now it has become, I think, more than 15, 16 pests are very prominent. This I think I always remember whenever I see a tanker. So this much of water we are using to produce 1 kg of grain. So that's why you have to be very careful when you are wasting rice crop. Some people they just throw away the, I think, plate meals also. That should not be done. And it means that we are wasting more than 5,000 liters of water. You can see that how, as I think our earlier student told, we have two systems like direct seeded rice, two main systems. Either it is direct seeded rice or a transplanted rice. Direct seeded means just grains will be used for sowing, whereas transplanted rice we uh, grow nursery, then after 30 days we transplant in a puddle field. But I am very much appreciate that unpuddle situation also she could able to get very good crop of rice. That is very good. But I feel that in all the situations in our soils where I am working there, black cotton soils, very difficult to transplant unpuddled rice. But it should we need to. But I have seen in UP and other places, the soil is so fragile. We can easily with one irrigation we can transplant it also. But again, in the direct seeded rice also, there are, I think people will go for totally dry situation. Then some people, they go for up to 30 days dry situation. Then later they will convert into like flooded rice, especially in canal areas where they get water at August 15th or August 28th. First 30 days, they will be totally dry situation, directly dry zone crop, but later they will convert into flooded system. So why we are shifting towards other crop establishment methods? This is a Punjab area. During especially, I think necessary is mother of invention. Where is, I think during 2019, I remember suddenly they have 1 million acres has converted into dry DSR, because there is no labor. They have to depend, especially labor from Bihar, to transplant their seedlings. So during that 2019, I think was possible. Then they went for I think this happy seeders, and which can plow it as well as which can also sow the crop. And there are a lot of soil health issues. I think you may be also aware of the amount of nitrogen they use it more than 400 kgs. And there is a one train that goes from, I think that's the train name itself, cancer train, because of high use of this chemicals and other things. Now they are realizing it, how to come out of that. Anything excess is always dangerous, so that we have to think about it. So whatever method we do it, either we do it SRI, either we do it puddle, whatever it may be, we need to see that productive tillers has to be increased. Productive tillers means panicle bearing tillers. That has to be increased. So that the effect of productive tillers is 50 to 60%. And then the number of field grains within the panicles, there are chaffy grain as well as the field grains. So that effect will be 10 to 20% because of this management, whatever we do it, sowing and other things. Test weight effect will be very less, 2 to 3%, very marginally there is changes. So another 1-2%. So we have to see that whenever we go for an area, we need to see that what is the square meter number of tillers, number of effective tillers. Based on that, we can judge what is the yield potential of that crop. So this is how the people grow for nursery for more than 30 to 45 days. So why people are promoting SRI means by this time 30-40 days most of the tillering cycles have been already completed because of this 30-45 days of nursery. But this is also very viable one because it has continuously we are going for this transplanted rice for many more years, like more than 400, 500 years. But still it is sustained because initial water stress will not be there because nursery we grow it in a very small area. So that same nursery we are whenever water is available we are transplanting to main fields. But there is a loss of some yield because of some people they just throw it and keep it there for 1 or 2 days. So the because of labor shortage. So we have, I think, our main mandate is to release varieties, any variety across the country. Whoever conducts rice research and other things, but they have to go through the process of initial evaluation, advanced evaluation of these entries with a control. Then they will be released from the Indian Institute of Rice Research. I think more than I think now 600 varieties, high yielding varieties have been released from this center, but not only IIRR credit, but because of all the centers which have been working on rice. These are some of the varieties which have been different ecologies. Naturally, irrigated ecology will have a very high share of the varieties. There are now, I think people are thinking about how to increase the nutrition quality of the rice. So many people are, I think, not only food security, but now everybody is interested about nutrition security. I was surprised to hear that some of the varieties have been very good medicinal value. That really it is very appreciable. And if they are controlling even cancer cells and other things, then it will be a great. We have released a first variety of high zinc variety DRR than 45, I remember, which is having high zinc. And then now we are not only releasing high nutrient varieties, we are also releasing about which can control different pests and diseases. 2-3 pests can be very effectively be controlled by growing this type of varieties, high yielding varieties. This is, I think, already highlighted you about this export of this rice. Not only basmati, non-basmati also we are exporting it. Hybrid rice, I think you all know that hybrids have a advantage over the conventional high yielding varieties. There is more than 3 million hectares of hybrid rice area is there. It will give around 1 to 1.5 tons per hectare of additional yield over high yielding varieties, but it is not spreading because of the high cost of the seed. I think cost of seed will be more than 200 to 300 rupees. These are some, as I told you, bacterial leaf blight variety, which I think you can really find a significant difference. If you go this variety, wherever BLB is prevalent, I used to survey in Kurnool area. The problem is BLB spreads because of irrigation water. If a field is infected with BLB, within 10 days you can see that whole area will get infested with BLB. And most of the farmers, they don't go for harvesting also. Once it is BLB is in, they just burn it with matchbox. So because they think that additional labor is waste, because they won't get anything from the that much problem is that there are very good varieties are available. We are also I think we are also releasing varieties which are efficient for the low phosphorus and low nitrogen also. We need not apply same 40 kgs of phosphorus. With the application of 20 kgs also, we can get the yields on par with the 40 kgs. So now coming to the SRI, we started working from 2005. I think many of you also must be knowing it. Norman Uphoff, who used to be the promoter of SRI by seeing in Madagascar. Only thing is we could not promote it in a better, I think, very large scale because of small nurseries and again labor requirement. Now what we are doing is now we are thinking of having a machinery which can transplant younger seedlings and we are also developing a tractor-driven mechanical weeders. So we need not, because another major problem in SRI is using that cono weeder, which takes lot of energy. So if a person uses cono weeder, then he will not come for next 2-3 days. So that's why we wanted to mechanize totally with tractor driven. I will showing some of the, and this is only just the basic principles of SRI, which can really change it. I think I am maintaining one plot where I think last 12 years I have a block with SRI and another without SRI principles, and I never got less than 20% of higher yields. So SRI has given out yield by 20% over the normal transplanted with reduced water, a reduced seed rate, and reduced inputs also. So that is what we are maintaining that same block for I think 12 years. We want to see that whether is there any depletion of nutrients or whatever it may be, that we wanted to try it. I think one paper, I think within few days it will be coming, where we have evaluated all 10 years of soil changes in the soil parameters, yield parameters. So those, I think I will share with you all the people when if it is published after publication. Early maturity, even 10 to 15 days, 10 days early maturity also saves lot of. Same time of sowing of this method, you can see that SRI will have this 10 days earlier. That one factor also makes lot of difference. 10 days of saying water, so many things. And if you can count it, what is that seed rate, 5 kgs per hectare versus 30 kgs. If you can multiply that amount of seed rate which we are using, per season this will be only in the state of Telangana, it is 100 crores saving of the seed. If you can really think about it, nobody bothers because it is only 20 rupees, 30 rupees kg. But if you can count it in terms of economic benefits, it is 100 crores per season per state, which we have done it. I think thoroughly we have done it. How much seed is going to save? And one advantage is hybrids, which are very costly. So with 5 kgs means everybody can go for hybrids using hybrids in this method. So these are some of the varieties we have tested, which are promising. We wanted to see that. I think medium and early duration are very good. Hybrids are very promising because of early vigor and effective number of tillers. And this we have quantified it. I think this is the experimental plot which I am telling you. For last 12 years, we are maintaining it with SRI block, normal transplanted block, and where we have computed water requirements and digital water meters. I think we have saved around 25 to 30% of water. These are, I think, data which I think you can clearly see that water saving. And this is a motorized weeder. I think I got it from Coimbatore only. Coimbatore or Chennai, I don't know. But this also we have used it. But now I think that this is also a problem. Now farmers are not willing to enter into the fields. You may be surprised to hear, I am every day being a farm in charge of our institute. Every day I am struggling to get labor for rice work. Side by side, one more institute is there, Indian Institute of Millet Research. Labor are interested to work there, but not in rice. So now what I have taken a decision is last month is we will pay any additional 500 rupees per month. Even then I am not getting labor because nobody wants to work in this. So next best way is go for mechanization. Whatever you can see the crop of this SRI, how the tiller growth and other things. You can see that aeration and other things. Now we are thinking of going for a mechanized transplanter, but many transplanters are available. But now what we are planning with, we are working with an NGO where we wanted to see that only 2 seedlings will be dropped at exact space so that SRA principle can be applied for that mechanized transplanter. We have conducted, our plus point is we not only conducting IIRR, once we see that that is a promising, then we will conduct in different centers across the country. So that's a strength of our Indian Institute of Rice Research. So we can authenticately say that I think this technology will work. I think already our earlier student told about aerobic rice, wherever water is shortage. So if you want to grow rice crop with 600 mm of water, So this aerobic rice is very useful. There are some very good varieties. I think I think 2022 we have released a variety, aerobic rice variety. So which can come up with less water, having very good root system. Student, student. Where is the student? Okay. So aerobic rice is, you are there. Okay. What is difference between aerobic rice and direct seeded rice? Huh? Okay. Okay. But in direct seeded, sometimes we don't puddle also. Direct seeded rice, there are two systems like dry direct seeded rice, wet direct seeded. Under wet we can puddle it. Under dry we don't puddle it. Then how this unpuddled dried DSR is similar with aerobic rice? What is the difference? Huh? Sowing is only dry seed only. In aerobic system, what we do is like wheat, we apply, we never make stress for the rice, water stress. So aerobic rice, what we do is whenever water is required, we will not flood it, but as per the requirement of the crop, we will supply the water. So that's why I am telling you that 600 to 700 millimeters of water is required for that. So under ideal water conditions, we grow the aerobic rice so that we can get yields on par even 5 tons also under aerobic rice situation. But direct seeding, even though it has taken under dry conditions, but there is no rule that we need to apply water every time or something like that. It can be also sometimes even dry direct seeded we can convert into totally flooded system, even though it is not puddle situation. But under aerobic situation, throughout the crop growth we maintain that aerobic situation. So we never flood it. But under DSR we can have, if water is there we can immediately puddle it. And aerobic system will having a better yield parameters. Will get better yields. Now we need to identify the suitable varieties, suitable management practices for the aerobic rice situation, so that we can get better yields. This is all about, I think you can remember, I think how we will grow the crop like wheat, how wheat can be grown, and I think 600 to 800. This is the way how we cultivate aerobic rice, and this also saves around, I think, 30 to 40%. I think I have seen many theses of drip irrigation from Coimbatore. So I think, but still, I have to say that I did not get more than 4.5 to 5 tons, sir, when we go for drip system. But still, I am not able to get the on-par yields of the transplanted. But water, I think definitely it is a lot of saving in the water. Water saving will be there, but I think there are very improved systems of drip has come, even subsurface drip system, and cheaper also. Earlier it used to be very costly, 1 lakh per acre. Now it is 20 to 25,000. They are able to keep the drippers for the per acre. So if that is the case, then we can easily adapt for wherever water is very shortage. These are the, I think direct seeding already you all know about it, and there are very good equipments like drum seeders are there. I think Tamil Nadu they have done one plastic drum seeders which are now very popular. I think Telangana, Andhra, earlier they used to give more than, I think, 50% subsidy for these drum seeders. This is the way how we go for drum seeders, especially used in the puddle situation, not in dry situation. But under dry situations, we can go for the behind the tractor drum. We can go for it. And this is one of the way. I think another 5 years. I think this will take mechanization will take a major role in case of rice production. And there are many technological options are there. We need to think about which can be even small areas also. If we can pull up 4 5 farmers together, we can go totally mechanized. People say that we are all having only small areas. How we can mechanization can be followed. I will show you. These are the 4 equipments which I think we are collaborating with one organization. These are the 4 operations. Like they plow the field, and they drill the seed, then they will adda means they will compact the soil so that it doesn't require any water till 20 days. Then again herbicide, they are also modified that total system into herbicide. Immediately they will apply this pendimethalin, uh, 750 ml per acre or something like that. So these are the 4 operations. They are so much standardized that 6,000 acres they complete in 10 days. Per day they do it around 1,000 acres. Same area earlier they used to take 2.5 months to do this transplanting. So, but they have standardized in such a way that whole area, that 6,000 acres area, they do it within 10 days. I think I have a video also. You can see that even fertilizer also they don't apply manually. This is a fertilizer spreader. So first one was fertilizer spreader. Then they are also using that tractor driven, this, what is that, drum seeder. You can see that I think weeders also there, and because I think hardly they use around 3 to 4 laborers only to feed the seed. Those things only they do it, and they have replaced. I think their cost of cultivation is reduced by 10,000 per acre. So can you imagine that? So that itself is a saving. If a rice farmer is getting saving 10,000 means that is a great saving for him. This is, you can see that what I am telling you, that 6,000 areas acres at a stage. You can see that crop will be very uniform. These are, I think, all explanations. What they do is they pull up all the tractors. So four tractors for these equipments will one by one after it. Like that, 32 sets they manage. But farmer has to pay for that one. If it is if his field is 1 acre, he has to pay for that tractors for hiring charges. Like that, 32 sets they keep it like this, all 4 equipments, and they complete within 10 days. These are the 4 operations. I think just I have given some details how they do it. So water saving is, I think, labor saving is very important. I think there is some video, but whether it will come or I don't know. Maybe I think that video is there. I don't know whether. Video will operate. Just click here. Just click. Not coming. Anyway, if time is there, I'll show it. Whole operations are there. I'm sharing this file here only. You can just, I think, whenever you want, you can just see that one. Whole operations, working condition have taken that. Small operations like how I think we can save more than 200 to 300 mm of water just by plugging that cracks. This is another. I think this is now getting it more popular because it can save around methane 20 to 30%. This alternate wetting and drying. Rice, I think we can grow rice with 2,500 liters. We can produce 1 kg. 50% we are just waste. I think what our farmers, what they say is because of flooding we can control weeds. That's why they are wasting more than half of the water. So that those things can be reduced by this alternate wetting and drying method, keeping flooding, then allowing it for drying for some time, then again water. So just by this method also we can save around 30% of the water requirement. This is, I think, many people must have heard of this plastic pipe, which is having around up to 15 centimeters. We will having holes, and we can only measure the what is the depth of water depleted from each day after 14 days of transplanting. Then we can irrigate it. I think when it is 5 centimeters below soil, then only we can irrigate it. I think we have demonstrated. I think now we are working with ITC, the corporate social responsibility. More than 1 lakh farmers we are supplying with this pipes so that they can follow the alternate wetting and drying method. Initially, what we used to do is we used to measure the water content with digital water meters. Even based on the depth of the water, also we can measure the how much water we have been using for the each irrigation. Okay. Now there is a system that we can also IoT based. We can also measure water depth. What is the water depth depleted by IoT based. I think with the mobile also we can see that every day what is the water depth that is being depleted in your field. So that type of technologies are available now. These are sensor based water management. Now we are working with a company called Cultivate, and which will be having a gateway which can cater the needs of more than 20 acres of area, surrounding area. We can keep these sensors in the pipes so that we can regularly monitor. For every hour we can monitor and we can collect the data in the system. So we can also give advisories. So which plot is requiring water, which plot is we can stop the water. So there are gateways, and this data will be again correlated with the weather data. If it is hot weather, then what is the amount of water which we have to give it? This is how it works. So, and we can also farmer need not go to field also. And what the system also tells that even motor also can be operated with this IoT based water management. So farmer need not go there that to put it on, put it off. And if it also calculates what is the time required to irrigate that crop. So 2 hours. So 2 hours, within 2 hours it will stop also. Based on the pump water flow and other things, it will stop the after 2 hours. In between, if there is a electricity failure, then they will calculate after that. That is the way that type of technologies are available now. These are the sensors, how they keep it in the AWD pipe, and then it can monitor. So we need not go to the field also to measure what is the depth of water has been depleted. So this is how we record the data IoT based. We need not worry about recording. Automatically we can take pooled data, we can get it. So these are all how much electricity saved, how much water saved per acre. Those things we can easily compute it. Even wheat crop also we can make it. Not only paddy crop, we can also at what depth we wanted to deplete the water also, that we can measure it. Each depth we can keep a sensor. So we can allow it to deplete water to that depth. I think this is, gateway. This is called gateway, which can cater the needs of more than 2 acres radius, and 200 farmers data can be taken. And now I think many technologies are coming up. There's a AI technology, even that drones. I think in coming years, I think some of the women also will be trained on drones, so they can. I think Prime Minister is thinking that they wanted to give drones for the women entrepreneurs, so that they can use these drones for the agriculture. That is the latest decision taken recently. Now precision agriculture, big data analysis. Now what we are doing is, where that 6,000 acres we wanted to run the spectral signatures. We want to run the drone with having a spectral camera, so that we will capture that what is the difference of the DSR versus transplanted. So based on that one, we can also see that wherever that DSR is prevailing across that state, that also we can think of. So I think there are a lot of opportunities for the students. They have to think about it, how best they can excel in their own activity. And this is one, I think you must be heard about Balasubramaniam, I think, who is nearby, and he has given a project. I think 2004 or 5, I remember. Now we have commercialized this product, and now it is, going for a large-scale production. Leaf color chart. So it saves around 20 to 30% of the nitrogen application. In the end, I wanted to say that we need to produce more, because population is increasing. Not only, don't think of only Indian population. We are also helping other countries where they don't have any land, they don't have any area. So they solely depend upon our, I think many people say that, I think our ancestors say that Vasudhaiva Kutumbam. So we are not only surveying for ourselves, we are also helping many other countries. So think about it, always remember a farmer, so that how best I can help him so that he is a happy person. And you imagine staying in rice field for whole day, how much hard work he is doing it. That itself is, I think, if you are doing some small thing which can benefit him, that is a great contribution for your lifetime. So this, I think, I don't want to say much, but a lot of challenges. If any crop is having around 350 to 400 tillers per meter square with 250 grains or 300 grains, then we'll get, this is the crop at Sri Lanka grown with SRA method. This yielded more than 16 tons per hectare. There is a potential. I think you told about potential, what is the genetic potential, but still we can, nobody's claimed that this variety will give more than 6 tons, but they reached around 16 tons per hectare. So genetic potential can be manipulated. I think I have finished. Thank you one and all. I think any queries or anything, I am ready to, anytime you can, I think first slide I have my phone number. If you are not noted down, anytime you can inquire or any help or from our Indian Institute of Rice Research. Thank you one and all. Thank you for your, thank you sir for giving this up.
Thank you, Dr. Rajendra, for sharing your vast experience.